The following is the video solution from JSDT Solutions. Okay, we have question 11, and question 11 says, a certain number of learners are sitting for examinations in mathematics, tourism, and geography. All these learners sit for at least one of these exams. And then they also tell us the total number of learners who sit for mathematics is 22, total of tourism is 16, total of geography is 18, and then they start telling us about the intersections. And so you can see from here where they say 5 learners sit for mathematics and tourism but not geography, then mathematics and geography but not tourism, and tourism and geography but not mathematics. You can see that all of them intersect. So we will have a Venn diagram and we'll have 3 circles that intersect. Okay, so we have 3 intersecting circles: mathematics, geography, and tourism. So when working with Venn diagrams, you need to start from the intersections. So we'll start here where they say 5 learners sit for mathematics and tourism, but not geography. If they're saying mathematics and tourism, this would be the intersection of maths and tourism. But now they say not geography. So you would exclude everything belonging to geography in that intersection. So it will just be this part. And how many learners are there? It's 5 learners. Okay, so we have 5 learners over here. And then they tell us that 4 learners sit for mathematics and geography, but not tourism. So mathematics and geography, that's that intersection, excluding tourism. So it's just this part over here. And that is 4 learners. Then 3 learners sit for tourism and geography, but not mathematics. So tourism and geography, but not maths. So that would be 3 learners over here. Okay. What other info do they give us? Here they say 6 learners sit for tourism only tourism. What they mean by that is it's not the entire circle. It's not everybody who sits for tourism, regardless of them sitting for maths and geography. This is people who sit for only tourism, so they will go here. Okay, so do we have an intersection, or do we have a means of finding that intersection? Okay, it seems like we do, because they say the total number of learners sitting for tourism is 16. Now, this is what this means. The total number of learners, meaning regardless of whether they sit for geography and maths, they sat for tourism. Okay, so they sat for maths and tourism. They sat for tourism and geography. Okay, but they all sat for tourism. So if this adds up to 16, then we can actually find out what this middle is. Because this is a total of 16, meaning everything here will add up to 16. So to find this, you'll say 16 minus all of these numbers. So 16 minus 6 is 10, minus 5 is 5, minus 3 is 2. So the middle is 2. So 2 learners sat for all 3 subjects. Okay, so we're done with that. Then the total number of learners who sat for maths is 22. So that again is like this. The entire circle of maths is 22. So 22 minus 2 already gives you 20, minus 5 gives you 15, and minus 4 gives you 11. So 11 is here. So that means 11 learners sat for maths only. Okay. And then we're done with that. Then lastly, we'll deal with geography. So the total number of learners sitting for geography is 18. Total number. So the entire circle of geography adds up to 18. So that's 18 minus 3, which is already 15. Then minus 4, which is 11, and minus 2, which is 9. Okay, so that's 9 over here. And okay, our Venn diagram looks good. Let's just see anything that we missed. Do you see that they say all these learners sit for at least one of these examinations? So what this means is everybody in this study sat for an exam, meaning you don't have anybody on the outside. And that would mean that this is our Venn diagram and we're done. We don't have anybody on the outside who is not included in any of these circles. Okay, so that is 11.1, and moving on to the next question. Question 11.2 says, calculate the probability that a learner chosen at random will sit for examination in at least 2 subjects. Okay, so let's break down what at least means. At least just really means at lowest, meaning the minimum amount of subjects that these learners sat for would be 2 subjects. Okay, so we're looking for learners who sat for 2 subjects. Let's see, at least 2 subjects. So looking at this, let's just look at each of these numbers and just see how many subjects they sat for. These 11 learners, how many subjects did they sit for? Do you see that they are only in maths? Okay, they're not in the mixture of maths and tourism or anything like that. So these learners sat for 1 subject. If you look at these learners here, they sat for maths and tourism, excluding geography. So they sat for 2 subjects. The minimum amount of subjects we are picking would be 2, meaning you're allowed to take 2 subjects or anything more than that. Okay, minimum amount, at least 2 subjects. So that would be 5 that we'll take. And then if you look at 6, 6 is for learners who sat for tourism only. That is 1 subject, so we don't take that. And then 4 is for maths and geography. So that's 2 subjects, we'll take that. And 3 is for geography and tourism. So we're also going to take that because that's 2 subjects. And the middle, these 2 learners, they sat for maths, tourism, and geography. That's 3 subjects. So that would be at least 2, at lowest 2 subjects. Okay, so we're going to have to add up 5, 2, 4, and 3. Okay, if you add 5, 2, 4, and 3, it gives you 14. So we have 14 over, and then the total number. So if this is 14, that already gives you 20. And then this is 20 on its own. So it's 40 learners in total. So that's 14 over 40, which of course will simplify. Okay, so at least 2 subjects, and then that simplifies. So 14 divided by 2 is 7, and divided by 2 is 20. So the answer is 7 over 20, left simplified. You can leave it as a decimal, that's perfectly fine as well. Okay, moving on to the next question. Question 11.3 says, determine if the events sitting for examinations in mathematics and sitting for examinations in tourism are independent. And then support your answer with the necessary calculations. Okay, so we're going to have to use the formula for independent events. If 2 events are said to be independent, then this is what is going to happen. So this means that the probability of mathematics and tourism would be equal to the probability of mathematics multiplied by the probability of tourism. Okay, that would be the case for independent events. So if they are equal, then it really means they are independent. Okay, so let's find the probability of mathematics and tourism. See that first. So this would be equal to, if you look up in your Venn diagram, tourism and mathematics, the intersection of them would be here, right? They didn't say tourism and mathematics and not geography. So this is this entire intersection, which is 7. So 7 over 40, that's the total we have. So we say 7 over 40, and we'll keep that. And now let's find out what the probability of maths multiplied by probability of tourism would be. So this is going to be, let's check, probability of maths. We already knew that because they said here 22 learners sit for maths. So that would be 22. This is the entire circle of maths, okay? That is 22 over 40. 22 over 40 multiplied by probability of tourism. And we know that tourism was 16 in total. So that's going to be multiplied by 16 over 40. And we just have to check if it actually does give you the same answer. So here you can actually find this as a decimal. It's better like that so that you can better understand what that number is. Okay, so 7 over 40 is 0.175. And then let's see what we get here. If we say 22 over 40 multiplied by 16 over 40, what do we get? We get 0.22. You see how those are not the same numbers? So that would mean they are not equal. So we can actually tell them these are not equal, and so therefore these events are not independent. Okay, so we can put a line through it here. It's not equal, therefore the events mathematics and tourism are not independent. And that is our answer.